Welcome, dear students, the sixth term students. I am Ravi Shankar. I am going to take the DSP part, that is the digital signal processing, in which I am handling second unit. It starts from DFT and FFT. So, today we shall discuss about what is meant by DFT and FFT. You know that DFT is an abbreviated form. The expansion of DFT is discrete Fourier transform. DFT means discrete Fourier transform. Here we are considering the discrete values of a continuous time signal function. Example, let us consider a function f of t which is equal to sine of omega t. So sine of omega t is a continuous function. This is represented by the graph like this. So f of t against t is a sine graph. This is a continuous function where the total length of this function is 2 pi. That is, omega belongs to 2 pi. Now, in this continuous time signal function, let us consider some samples of this function at regular intervals of time. Example, I will consider the sample of this function at this point 1, 2, 3, 4, 5, such that all the samples must be equally spaced. Each samples are taken at regular intervals of time. The 0 is the first sample, second sample, third, fourth, fifth. That we have considered 5 samples of this continuous time signal function. Then writing these samples. Zero's function. The 0 sample, the function value is 0. This is the first sample where this is the height. Next sample is again 0. Next sample is negative. And again next sample is 0. Thus we have taken 1, 2, 3, 4, 5 samples of this continuous time signal function. Then these samples are called DFT, discrete Fourier transform of this continuous time signal function. Thus, DFT, discrete Fourier transform of any continuous time signal function is equal to number of samples, say n, equal to the length n of this continuous function. So DFT of any time signal function of total length n is the number of samples n of that function. So taking the number of samples of a continuous time signal function is called discrete Fourier transform, DFT. Mathematically we can express DFT as like this. If x of n is any continuous time signal function, it is a continuous function, then DFT of this function is taking number of samples. Let n is the number of samples. Then this n, small n, can have total number of samples n. Therefore, the small n is 0 is less than or equal to n is less than or equal to n minus 1. Including 0, there are n number of samples. N minus 1 samples, but including 0, total is 1, 2, 3, 4, etc. up to n minus 1, and 0 is 1 number of samples. Therefore, total number of samples here it is n. So, if n is the total number of samples, then 0 is less than or equal to n is less than or equal to n minus 1. If we take a continuous time signal function of DFT of 10 point DFT, n is point, 10 point DFT, then 0 is less than or equal to n is less than or equal to 9. 10 minus 1 is 9. So from 0 to 9 you have 10 samples. So taking the number of samples from the continuous time in signal function is called DFT. Mathematically we can express this DFT as if x of n is a continuous time signal function such that 0 less than or equal to n is less than or equal to n minus 1, then DFT of this function is represented as capital X of k, which is equal to sigma n equals 0 to n minus 1. This shows that there are n number of samples. N minus 1 including 0, one more sample, n minus 1 plus 1, therefore total n number of samples into x of n wn nk. This is the mathematical expression of DFT of the function x of n. Capital X of k represents the DFT. Small x of n represents the continuous time signal function. Then DFT of x of n is x of k equals sigma n equals 0 to n minus 1 x of n into w suffix n to the power nk, where k can have values from 0 to less than or equal to k less than or equal to n minus 1. K can also have n number of samples, 0 less than or equal to k less than or equal to n minus 1. Here k represents which samples among n, whether first sample, second sample, third sample, and etc. Since k can have n number of samples, therefore k may be any values between 0 to n minus 1. So this is mathematical expression of